Assalamualaikum, we are from Group 5. I'm going to present about the topic multiprocessor versus parallel processor. So this is our group members. The table of content, we are going to talk about the introduction, the organization block diagram, performance, advantage, disadvantages, and conclusion. For the introduction, I will be presenting it. For that, my name is Al-Halimah Al-Barakis with USD. My mentoring number is 214822. I will be explaining about what is multiprocessor and parallel processor, also briefly about the issue that we're going to talk in Amazon Web Services and Google Cloud Platform. Firstly, Amazon Web Services is one of the world's center of attention when it comes to attending IT infrastructures in services that extend to businesses as well, by implementing now commonly known as cloud computing. So AWS also provides high security, fault tolerance, and scalable and also low cost infrastructure platform. By using the cloud computing also, they manage to make purchases, operating and caring for the physical data and the servers. And they can also use the AWS for obtaining as needed technological services such as processing power, storage, space, and databases. Whilst in Google platform, it is a collection of physical assets such as computers and hard disk drives, as well as virtual resources such as virtual machines. And that is housed in the Google's data that offers a public cloud computing services in the globe. And it is also has influenced a part of our life where it allows the access of wide ranges of software and hardware, and also networking technologies. A user can also take advantage of the Google's infrastructure by delivering smart, secure, and highly adaptable services. Next, I will explain about what is multiprocessor. Multiprocessor is a computer system that contains two or further central processing units, which is the CPUs, and it processes two or further different portions of the same program, and each of which has the participated main memory and the peripherals. The key point here is to increase the system prosecution speed and has its own fault tolerance and operation matching as the secondary pretensions. Also, multiprocessor system can outperform a single processor systems in terms of performance, especially for jobs that can be readily parallelized. Lastly, the characteristic of multiprocessor is that all CPUs can have access to the same participated memory. So in here, we have two examples from one which of in AWS and the other is from GCP. In AWS, they use multiprocessor in their Elastic Compute Cloud, which is EC2. It is a service that allows commercial subscribers to execute operation programs on a computer that demands calculating power, storehouse, and databases to communicate with each other. It is also to employ expensive participated network that includes hundreds of layers, and it needed the multiprocessor to deliver those systems. Lastly, these systems are also built to accommodate a wide range of workloads from small to large scale of business results. In the GCP, it have virtual machine in Google Cloud. The multiprocessor is used when because when we create a virtual machine instance, there will be a specified machine series and a machine type for the VM. Next, machine series corresponds to one or more CPU systems. Therefore, the results of this brings to VM to be accessible to multiple virtual processor cores, which stimulate the act of multiprocessor system. Next is about parallel processor, which is a computer technology that uses two or more processors to perform program instructions by dividing them among the processors to complete a single job more quickly. The performance of various programs on parallel processing components with shared memory is heavily influenced by the methods used to arrange or to schedule these applications on physical processors. Moreover, the messages are used to communicate between job scheduled or processing components. Since the processors have distinct instruction counters, each one runs its own task program. Next is the example in Amazon, in AWS, where they use in Amazon Elastic MapReduce, EMR, which is allow the clients to run advanced workloads and high performance computing applications. It is also known in their AWS step function, where it is being recognized as one of those services for helping developers to build distributed application by using the parallel processing. Next, in GCP, we have the parallel processor in their Google Cloud AutoML, where AutoML is an emerging trend with active research data. Therefore, a distributed processing in a typical machine learning algorithm efficiently train and optimize the machine learning platform on huge data sets of which are increasingly relied upon for routines. It enhances the significant boost in performance, handles scarce resources better, and accelerate data-intensive operations. That's all from me. I will pass on to my next partner to move on. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shafiqah binti Badr Azmi with matrix number 216427. Now, I would like to continue this presentation with the organization block diagram. Firstly, the diagram shown is the block diagram for a multiprocessor system. As Hani has explained earlier, it can consist of 2 or more processors. The shared main memory and the input-output devices are accessible to all processors via the interconnection network. Meanwhile, the diagram shown below is the time-shared bus. It is the most common organization for personal computers, workstations, and servers. Basically, it is the simplest mechanism for constructing a multiprocessor system. Plus, to facilitate the transfer of input-output subsystem to the processors, few features are added to the organization, which are addressing, arbitration, and time sharing. Firstly, addressing is the feature that must be possible to distinguish module on the bus in order to determine the source and destination of the data. Secondly, arbitration is when any input-output module can temporarily function as master, where a mechanism is provided to arbitrate competing requests for bus control using some sort of priority scheme. Lastly, time sharing is when one module is controlling the bus, other modules are locked out and must, if necessary, suspend operation until bus access is achieved. Next, for the parallel processor, on the other hand, execution of tasks is divided into smaller parts, where the programs are split and executed by several CPUs at the same time, and the process results are then recombined. So, to explain this diagram, let's say a program is required to be executed by a single CPU in 5 seconds time. Hence, by using the parallel processing system, the program will split into 5 and will be executed by 5 different CPUs at the same time. As a result, all the tasks are being executed in only 1 second. So, the difference between these two is that the multiprocessor will perform tasks using many processors or cores within a computer system. Meanwhile, the parallel processor will divide the program part by part. Now, I would like to pass this presentation to Izul for the performance.
Assalamualaikum and hi everyone. My name is Muhammad Izul Fidai bin Muhammad Zaki. My matric number is 214301. So today I will continue the presentation about performance. So let's jump into the comparison for the performance of multiprocessor and also parallel processor. For the performance of multiprocessor share a common memory and work together to execute tasks. It can achieve high performance by efficiently utilizing shared memory, minimizing memory access, contention, and optimizing synchronization and cache coherence. Next, for the speed up. The speed up for the multiprocessor, achieving linear speed up in a multiprocessor system can be challenging due to factors such as communication overhead, memory access contention, and also synchronization. Next, for the efficiency. The efficiency is calculated by dividing the achieving speed up by the number of processor used. Higher efficiency means better utilization of processor. Memory optimization techniques, cache coherence protocols, and workload distribution strategies to improve efficiency in multiprocessor system. Next, for the parallel processor. For the performance of parallel processors for multiprocessors work together in parallel to execute tasks. It can achieve high performance by effectively distributing workloads, minimizing communication overhead, and maximizing parallelism in task execution. Other than that, for the speed up, multiple processors work together to execute a task in parallel. Speed up in a parallel processor system would increase linearly with the number of processors used. So the higher the processors, the graph will be linearly. And last but not least, for the efficiency of parallel processor, efficiency is calculated by dividing the achieved speed up by the number of processors used, meaning that for the higher, if the more processors used, the higher the efficiency for the parallel processor. For the parallel processor, it focuses on optimizing task scheduling, load balancing algorithm, and communication protocols to improve efficiency in parallel processor system. So I think that's it for me. Thank you.
Now, let's talk about the advantages that multiprocessor and parallel processor has on AWS. Now, let's start with parallel processors. Number one, increased computational power. Parallel processor allowed users to execute multiple tasks simultaneously, leveraging multiprocessors or cores. This results in increased computational power and faster process of complex tasks. Now, second one, improved performance and scalability. By allowing the distribution of computational tasks across multiple processors, it enhances performance and scalability. Number third, faster data processing. Parallel processing allows the data-intensive applications to process and analyze large data set more quickly and easily. Cost of optimization. Parallel processing contributes to cost optimization. It distributes the workload among multiple processors, and by doing it so, it reduces the time required for computation, resulting in lower costs. Now let's compare it with GCP, parallel processing services. Both AWS and GCP offers services that support parallel processing. AWS has Amazon EC2 instances with multiple cores or GPU instances. Similarly, GCP also offers compute engine instances. Now, regarding the performance and scalability, both the companies allow users to distribute computational tasks across multiple processors. They also offer auto-scaling features as well. Now, regarding the data processing, both provide faster data processing. AWS offers Amazon EMR, which manages big data, as well as Google also has services like BigQuery, Dataflow, and Dataproc to handle large-scale data processing and analysis. Now, regarding the cost optimization, both companies reduces computation time by distributing the work to multiple processors, which eventually reduces the cost also. Now, let's talk about the advantages that multiprocessors has on AWS. Number one, increased computational power. Multiprocessors allow tasks to be executed in parallel across multiple processors. This significantly enhances the overall computational power and performance of application running on AWS. Number two, improved throughput. Multiprocessors enable higher throughput by dividing the workload among multiple processors or cores. Multiple tasks can be executed simultaneously using multiprocessors, resulting in faster data processing, reduced latency, and improved overall system performance. Now, regarding the fault tolerance and high availability, multiprocessor architecture can enhances fault tolerance and system reliability. With AWS, workloads are distributed across multiple processors or instances through features like auto-scaling and load balancing. The workload can be automatically shifted to another processor in case of any hardware failure or maintenance events. This ensures continuous operation and minimizes service interruptions. Regarding the efficient resource utilization, in multiprocessor system, computational tasks are distributed efficiently to make efficient use of resources. This helps optimize resource allocation and reduces resource wastage. Now, let's compare it with GCP. Number one, increased increased computational power. Both the companies leverage multiprocessor architecture to enhance computational power. By distributing tasks across multiple processor or cores, users can achieve faster processing, quicker data analysis, and better handling of large workloads. Regarding the improved throughput, through AWS and GCP, multiprocessors contribute to improved throughput. The workload is divided among several processors or cores. The workload is divided among several processors code, allowing multiple tasks to be executed simultaneously. This results in faster data processing, reduced latency, and overall system performance improvements. Now, regarding the fault tolerance and high availability. In both the companies, workloads are distributed across multiple processors or instances, ensuring redundancy and minimizing service interruptions. In case of any hardware failure or maintenance event, both platforms offer features like auto-scaling, load balancing, and automatic workload shifting. Efficient resource utilization. Efficient resource utilization is a key aspect of both AWS and GCP. The use of multiprocessor system makes optimal use of resources by distributing computational tasks efficiently. Now, this was the advantages.
Hi, my name is Muhammad Shakir Nazmi bin Abu Bakar and my metric number is 215932. Next, I'm going to present on the disadvantages of parallel processor and multiprocessor. So here is a list of disadvantages. First of all, let's get into the parallel processor. One of the disadvantages of parallel processor is high complexity, communication overhead, high cost, and scalability challenges. Meanwhile, for multiprocessor, high complexity, problem with compatibility and software support, problem with debugging and testing, and scalability challenges. Now, I'm going to present on the comparison between these advantages of parallel processors utilized by AWS and GCP. First of all, let's see the complexity of both of them. For AWS, it has high complexity due to its broader range of services and configuration available. Meanwhile, for the GCP, it is more to simple architecture since their services and tools are designed with ease. Next, the communication overhead. Both AWS and GCP parallel processing involve in communication overhead. However, it can be varied based on specific services and configuration used by AWS and GCP. And in order to minimize delays, effective data exchange and coordination mechanism is required. Other than that, resource consumption and cost. For the AWS, it demands high costs since it requires additional instances or higher power instances. Thus, it leads to increase in operational expenses. On the other hand, for GCP, the cost can be varied based on the service use and resource configuration. The last one is scalability challenges. The common factor causes challenges in scalability for both AWS and GCP are communication overhead, data dependencies, and synchronization bottlenecks. For AWS, coordinating large number of parallel processes across multiple instances can decrease the scalability. However, for GCP, it has GCP serverless options which can simplify the scalability. Next, I'm going to compare the disadvantages of multiprocessor utilized by AWS and GCP. For the first one, which is complexity, the architecture of multiprocessor in AWS and GCP are both complex and it requires the understanding of the ecosystem, services, and configuration. Other than that, problem with compatibility and software support. For AWS, not all software or libraries are optimized to take full advantage of multiprocessor architectures. On the other hand, GCP provides flexibility for developing applications due to the existence of extensive language and framework support. Next, the problem with debugging and testing multi-threaded or distributed applications on both AWS and GCP is both of them are complex to do due to the distributed nature of the systems. In order to help this problem, AWS provides AWS X-Ray and CloudWatch, meanwhile GCP provides Stackdriver for monitoring and debugging tools. Lastly, scalability challenges. Both of AWS and GCP face with scalability challenges. In order to handle increase in workloads, AWS provides various scaling options like auto-scaling and EC2. Meanwhile, GCP offers managed instance group and load balancing for distributing workloads.
Okay, after hearing all the explanations, we can see that both multiprocessors and parallel processors they offer significant advantages in terms of boosting the performance and computational power when being used in cloud computing environment like Amazon Web Services and Google Cloud Platform. So for multiprocessors, it consists of multiple processors sharing a common memory, provide improving the performance through efficient communication and coordination. With sharing memory, tasks that require extensive data sharing can benefit from reduced communication overhead and faster memory access. Uh, Amazon Web Services using the multiprocessor system in services like Elastic Compute Cloud, and for Google, they use multiprocessors in their virtual machine, which offering reliability and high performance computing capabilities. Okay, move on to parallel processes. Parallel processes divide tasks into smaller tasks that can be executed by multiple processes. By doing this approach, it maximizes the parallelism and achieves significant speed up, particularly for tasks that can be easily parallelized. For Amazon Web Services, uh, Amazon Elastic MapReduce and step function using this approach, which is parallel processing, to process massive data volumes and execute distributed applications efficiently. For Google Cloud's machine, it learns services also using this approach to train and optimize models on large dataset. So for both approaches, which are multiprocessors and parallel processors, they have advantages in terms of increasing the computational power, improving the performance, and boosting the data processing, also the cost optimization. However, their implementation and integration differ within the Amazon Web Services and Google Cloud ecosystem. Uh, Choosing these two approaches depends on specific requirements, depends on the workload characteristic, also the existing infrastructure. So for conclusion, the choice between multiprocessors and parallel processors depends on the specific needs, on your workload characteristic of the cloud computing environment. Uh, Both have their own advantages. Both approaches offer significant performance benefits and utilized in various Amazon Web Services and Google Cloud Services. By understanding advantages and disadvantages of each approaches, it can help the organization to decide whether they want to implement uh, which approaches in their cloud infrastructure. That is all for me. Thank you.